All right, team. So we are going to be using the ladder strategy to not only find the GCF, but we're also going to use it to find the LCM as well. And what's cool is it's sort of like a twofer, right? If you use this strategy, you can find either without having to do too much extra work. So it's pretty handy. So there are some written instructions here that you can always look back to. And here is an example that's already done. So we can kind of refer back to this in just a moment to find out what this means on the left for GCF and in the L for LCM. It's just sort of a handy way that you can kind of maybe remember. So we're going to do an example together. So we want to find the GCF, the greatest common factor, right? Factors go low-de, low-de, low. And we want to find the least common multiple of these numbers, 36 and 44. So what we're going to do is we're going to use these little draggy things here. So it's like a little sticky note. And so what we're going to do is I'm going to just drag a little sticky note up. And as I do that, I can click inside and I'm going to be typing in a prime number that is divisible by both of these numbers here. So we don't really want to choose one because that's not going to help us break the numbers down at all. So instead, we want to try to find another number that has a pair, right, that can multiply to hit these numbers or that divides them both evenly. So I know they're both even, so I'm just going to use 2. So 2 into 36, I can pull out. Let me pull up another one of these little stickies. I'm going to say, all right, it's kind of, right, not an accident that these, I don't know where my little sticky went. Come on, little buddy. Why aren't you dragging? There we go. Okay, it's not an accident, right, that this looks like an upside down, this little L, it looks like an upside down division problem, right? And it is a division problem, right? You can also call this ladder method. Some people call it the division method. So 2 times what pair gets you 36? Well, times 18. So we're going to do the same over here. So we're breaking these down, right, into their pairs. So 2 times 22 gets us 44. So then we're going to say, all right, well, we have this next layer to our ladder, right? Another rung, if you will. So we have 18 and 22. Well, they're not prime, right? And I know that because they're at least both even, so they can be cut in half. So how many 2's will it take to make 18? It'll take 9. And how many 2's will it take me to make 22? Well, it'll take me 11. Come on, 11. I believe in you, 11. Type in. Okay, so it'll take 11, right? So now we look at these and we say 9 and 11. Are there any other factors that they share? I have sort of a tree, right? Or I have a factor T. Are there any other things, any other numbers that I could pull out of both of these? And I cannot, right? So and you can use the divisibility rules to help you with that too. So when we get to this spot, what's going to happen is to find the GCF, we're going to look to the left. Okay, GCF on the left. So these prime numbers over here, right, are going to be what we can use. So I'm going to end up doing 2 times 2. GCF on the left, our greatest common factor becomes 4. We multiply this prime string together to hit or to discover our greatest common shared factor. We're going to then to find the LCM, the L, emphasis on the L, see how this kind of like looks like the letter L in blue a little bit. We're going to end up multiplying all of these primes together, right, to get our string 2 times 9 times 11. And when we multiply these primes together, we're going to get a big old beast of a number, which is 396. So you can see how it wouldn't be super friendly or efficient to necessarily do the listing method in order to find the LCM of 36 and 44, right? You would be counting for a very long time, 36 and so on, creating these lists, right, to find your way up to 396. So this strategy can be pretty efficient.